can share it. Okay, Adrika, we're recording this for you, okay?
Good afternoon, good evening, Adrika. We just realized we ought to record it for you, so we've already gotten started, but I'm going to go back a little bit for your sake and just go over this quiz here on chapters 11 and 12 from Mortison's book on searching for Adam. And so question number 2 then, that the 10 design features required for upright walking, it's found in humans, not in apes, and that is true. And page 332 is one passage, but the whole chapter really. And then number 3, the transition from quadrupeds to bipeds, which began in arboreal, which means tree-dwelling apes walking in tree limbs, that's false. We read that evolutionists will try to say that, but the feet of apes are so totally different. They're made to grasp the limb and not to walk on solid ground. Now, question number 4 then. And so that brings us down here. Sandra, question number 4, please.
Humans are purposefully over-designed with a high degree of functionality in order that they might serve their creator and their fellow man. True.
Yes, that is true. I don't think anybody's going to pretty well argue with that. Being overly designed, that's what those 2 chapters were really all about.
Right.
And Sandra and I have been visiting for quite a while about it. The other 2, did you find these chapters kind of delightful?
Yes.
Yeah, easier to read and really interesting, and you could follow through the logic and everything else. Yeah, all for the glory of God. Okay, question number 5 then. And that would be DL, back to you.
Apes. Apes have the ability to play the piano if they had the corresponding intelligence. False.
Okay, right, and I agree with you, but why? Why is that false? That's right. They need more than intelligence. They don't have the dexterity. Yeah, their fingers aren't created this way, you know, in all of that. Okay, and then question number 6. And we're coming around real quick. So, Judy,
there are about 50 separate muscles in the human face, which gives the unique ability to make about 10,000 different facial expressions. That's it.
everybody get true on that? 10,000
That's amazing.
facial expressions.
Yeah.
And really, you can communicate without saying a word.
Yeah.
And especially people that know each other.
Yeah, especially me.
Yeah, it's amazing. You see a husband and a wife, or 2 gals that have been good friends for years, and they're in a whole crowded room of people, and they're communicating back and forth, never saying a word, but they both know what they're talking about. It is, isn't it? Huh? And the picture in the book of this 5-year-old,
Yeah.
you know, take a 5-year-old and tell, no, make a sad face.
That was his move.
Yeah, I mean, really, it's just amazing. All of the very fine muscles that a human being has in their face.
Yeah, that's amazing.
Yeah, and of course, the next question then, Sandra, did you have the last one? No.
No, it's
All
not.
right.
God created mankind uniquely to be able to communicate visually a wide range of emotions. True.
Okay, that is true. And basically, those 2 questions, or 2 statements there, are very much the same. But this whole idea of communication, made in the image of God. You know, animals do not have, I mean, they've got intellect as far as they can think, they can reason to a certain extent, they can do all kinds of things. Some of their physical abilities exceed ours as far as speed or whatever it may be. But to have that personal relationship. Now, they do have a personal relationship. Watch a mother lion take care of her cubs. And they come up and they rub alongside her and she licks them and everything else. Or a dog. Can a dog show some affection? Oh, yeah. But not like a human being.
Right.
And one of the things, I don't have it on here, but I want to emphasize it. are the whites of your eyes. It is interesting that the animal kingdom, they don't show the whites of their eyes that much. And if you look at your dog, I mean, there is white way back there, but you look at your dog, sometimes you don't know if that dog's looking at you or not. But God created us in such a way that with the white of the eye, you can tell if somebody's actually looking at you or if they're looking off or whatever it is. You're talking to somebody and they're looking over your head, not paying a bit of attention to what you're saying, and you pick up on it immediately. You know, just that kind of a look. That's all it takes. And the animal kingdom doesn't have that ability. And God created us to relate to him and to each other. We are social beings. And that ability to communicate is so vitally important. And nonverbal communication. Now, this is a statement that I have read and read it repeatedly from those that specialize in communication. Basically, what they say is that the verbal communication is only about 7% of communication. The words you choose to use. 93% is all of that non-verbal communication and context. You know, I love you too. Mean a lot of different things. Depending on the context, depending on the expression, the tone of voice, all of the non-verbal things. You know, I love you may be sarcastic.
Yeah.
You know, there's just so much involved in that. And many times what we say is not as important as how we say it.
Right.
One of my deacons at Olivet, he has really struggled. And he's not going to run again this next year. And I visited with him. And the reason he's not going to be elected again as a deacon, he's got all kinds of ability and talent. We really need him. He's really sharp. He just doesn't feel the other deacons respect him. And we talked about it. I know why. When he disagrees, it's not what he says, it's how he says it. He comes across angry and attacking. Well, if you talk to people that way, they're not gonna respond right. You know, and it's not what you say, it's how you say it. And God created us as social beings to interact. And all of the facial expressions, everything that we've got, it's amazing how God created us. And none of the rest of the creation has that ability. Yeah. Now, animals they communicate with each other, but not with the expressions that we can. They can't communicate the emotions and all that kind of stuff that we can. They do it on a very basic level. That human beings are unique. Okay. All right, Dale, what's the next one now? Number 8.
Your human speech up to 100 muscles are involved in controlling the shape of vocal cords. Tongue, lips, shape of the throat. True.
Yeah. And it was amazing, all the things that he mentioned. He spent quite a bit of time talking about what's involved in verbal communication. And even the range, I don't know if it was in here or not, but the human range as far as being able to go low and high, we've got a great range. And they have all the ability to close down areas and resonate and all of that, and pronouncing all the words to lips and how they can pronounce words. And some words, if you kind of close your throat or you open your throat, even when it comes like to different languages, you know, there's some languages that have a lot of clicks, some indigenous languages, very hard for missionaries to learn. Because those little clicks that are in there are part of it, you know, and all of that. Do you know the difference between the Spanish R and the French R?
Well, I know, because I took Spanish in high school and I remember we were supposed to roll our R's.
Can you do that?
Now?
A lot of girls, a lot of women have a hard time. I don't know why.
Okay.
I think it's because little boys play with cars and go. Little girls don't learn that for some reason. And it's amazing. I substituted Sunday. I just recently gave up my Sunday school class. I've got another person teaching it. So I'm kind of free. My wife teaches 2- and 3-year-olds.
Oh,
So I sit in with her last Sunday to help her. Her helper wasn't there. Oh, we had a ball. But it was amazing. The little boys immediately went for the cars and the trucks. And the little girls went for the cooking area. We've got all this kind of play, food and stove and all of that. And then the babies and their beds and all of that. It's just the difference between boys and girls. But anyway, the Spanish R is the tip of your tongue. What's the French R?
I remember.
Ah,
Oh.
the back of your throat.
Okay.
Yeah.
I can't whistle, so I have a hard time listening.
Marlene and I took French together in Bible college. Fact is, that's kind of how we got more acquainted. And one day just happened, she was talking about having trouble with her R's. So I took her to the water fountain. I said, now gargle.
Oh.
She still had a hard time with it. But at any rate, all of the variety, animals communicate.
Mhm.
All the apes have their different grunts and stuff of that nature. Birds have whistles or whatever it may be, or clucks or something of that nature. They communicate on a basic level. But they don't communicate abstract thought.
Right.
They don't have a vocabulary any bigger than just what they
Right.
always use.
Right.
If you study birds, they've got one song for this, they got another one for that, they got another one for this. And beyond that, they got one for danger, whatever it may be. They've got one for attracting a mate that they sing in the spring. But you can catalog the entire variety of a certain bird species and on one page, less than a page. And beyond that, there's no other communication. And even your porpoise and whales and stuff, they've got great communication, but it's still very limited. And what did he say in there about our vocabulary?
I was looking at that. It said it's like the English language contains over 500,000 commonly recognized words.
Yeah.
And then we have the number of possible words in the English language is far greater than 1 million.
Yeah, that's because you got the various tenses and stuff in the same word. To sing, you can put it past tense and future tense and all of that, and plural and singular and everything. There's so much variety and stuff there. It's just absolutely amazing. Okay, we'll continue then. Number 9. I'm not sure who it is. All right.
The only difference between the human brain and the gorilla brain is the size. False.
That is false. There's so much more to the human brain than just its size. There's just an awful lot there about the way we function, different parts of the brain that are used for different things, and even the language part. It's a large part of our brain is dedicated to language. And how quickly we can speak and hear and interpret and argue and all of that. It's just amazing. Yeah. And then I think, Judy, we might have skipped you there. Number 10.
Genetic variability is a design feature that emphasizes individuality and beautiful variety.
Yeah. And we've talked about that so much. This whole idea of individuality. And I think it says genetic, doesn't it? Genetic variability. I mean, this had to be God's design
Mhm.
because the variability among the human race is so great.
Yeah.
Yeah, that was interesting on the breakdown of the African people.
Mhm.
On how many, well, I think that was chapter 10, so I'm sure y'all talked about that last week.
Do what now?
In chapter 10, it was talking about how the African family,
Yeah.
people in Africa, there were so many variations within that group
Oh, yeah,
of
absolutely.
people.
Yeah.
I found it interesting, but I think that was chapter 10.
Yeah. It talked about that, how evolution says that, we all came from one common
Right.
source in Africa and everything back out and stuff, whereas Shem, Ham, and Japheth after the flood, and then the Tower of Babel would give all that variation. But just take the African appearance. I mean, it's as varied as you can imagine. From the features that many times are kind of exaggerated as far as lips and nose and all of that,
Mhm.
and yet the very fine features of many. You got your pygmies, you got your giants, you got, the variation between any group. And it's amazing. When we're not acquainted with people, it's hard to distinguish. In other words, we got several Chinese.
Yeah.
Well, in the beginning, I kind of lumped everybody together. They're Chinese. They got certain facial features, etc. Man, once you get to know people, they're as different as day and night from each other.
So I guess because I've never really looked hard enough or whatever, because I cannot tell a Chinese from a Japanese. And maybe I'm not looking right or whatever.
Really, I'm not sure I can either. I can tell the language difference,
Okay.
but there's just enough difference there, but by looks. And if I stereotyped, which means probably most Chinese are shorter than Japanese,
Oh, okay.
that would be a stereotype I would just kind of make up, because I know the Japanese people I know, the Chinese people I know, I'd be doing it. But what I'm saying is, no matter what nationality you are, the variation between the individuals is so great.
Yeah.
Well, that's just like you mentioned, like it's either Japanese or Chinese or shorter, and then they've got some basketball players in the NBA.
That's right. That's
that are,
right.
7 feet
Super
or
tall,
something,
yeah.
You're like, wow.
So it's, that the variety is what God delights in.
So I'm joking, but they all look alike, don't work in any case.
No, it's just because of familiarity and everything else.
Yeah.
But it's always fun to see a little bitty child that's just barely learning to walk. And they may see somebody they think maybe is their dad or their mother, the dad mainly. And they get up there and he turns around and all of a sudden, you're not my dad. A baby picks out faces.
Yeah.
They can tell the difference, the variety. And it's just absolutely mind-boggling. And what they tell me is that there's enough genetic variety that no matter how many years you want to put in there, no matter how many billions of people you want to try to count, there'll never be two that are actually identical. And even identical twins aren't really identical. But, barring identical twins, the variety and everything else that's there is just absolutely amazing. God values the individual.
Well, I've looked at this show periodically. I forget, I think it's called My Big World or My Little World, where they show there's two twins, both the parents are, I guess they call them little people.
Yeah, I've
And
seen
they
that
have
advertised.
twin sons, and one is just regular, and the other son, the other twin is a little person, a little people. I'm like, wow. Came out of the same room.
Yeah, well, fraternal twins can be as different as day and night.
Yeah.
We had two fraternal twins in California. One was very tall, red-headed, freckled. The other one was very short, dark hair, and olive complected skin. And they were twins. You say, oh yeah, they're kidding me. No, they weren't kidding. They were twins. Yeah.
I know my sister went to school with fraternal twin girls. Their parents one parent was white, one was black. Girls were born, one took like after the father
Mhm.
and the other
One
one took
like
after the mother. I'm like, wow, they look different as night and day.
Oh, yeah.
They were,
I was trying to find those twins that were quote unquote identical except for their skin type. It's the same thing that you were saying.
Oh, okay.
I was trying to look it up,
okay,
but one had blue eyes, and the
okay,
other one had brown eyes, and the other one had darker skin and lighter
Okay.
skin, but they were identical.
wow, now that's,
I mean, everything else looked the same, but they looked so different with the blue eyes, straight hair, and the brown eyes,
wow.
kinky hair, but like gray hair. I'm trying to find a picture of them.
But that genetic variety that God built into Adam and Eve
It's amazing.
It is,
is so great. And it gets passed on down through the generations, and you skip generations and everything else. And if there's a recessive gene, it's called a carrier.
okay,
It may not show.
right,
It's not gonna be, color blindness is a recessive gene,
okay,
and females carry it. Females technically are not supposed to be colorblind. Now, that's not always true.
okay.
One of our teachers, a female, was colorblind to a certain extent.
Oh,
But color blindness basically is if you've got parents and one of them, unless they carry the color gene, the colorblind gene, their kids cannot have it.
oh,
But if the other parent has it, it can be recessive and hide, and generations down the road, it might come out.
oh.
Interesting.
Yeah,
It
it's
is.
fascinating.
But my son-in-law is colorblind. My
Mhm.
daughter has to, when he lays out his clothes, she has to pick them out for him because he can't tell the color.
From what I know about color blindness from my uncle, because he was colorblind, or he is colorblind. And red and green look the same. However, painted green and natural green, chlorophyll in the trees, is as different as day and night.
Oh,
And he was in the army and he had to hide his color blindness. Because when they camouflaged, in practice and stuff, they would have mock theater and stuff. And he see a camouflage tank down there, it looked bright red to him,
wow.
because the green that's painted green and the natural green are two different colors.
That's how the benefit of it.
It was, but he wasn't supposed to, they weren't supposed to, if they knew it, they would have put him in a different position.
Mhm. Yeah,
He was also an electrical engineer, and he had to work with color-coded wires.
wires. Hmm.
He had to go to the source. He had to work real hard to make sure he got the right wire.
I can imagine. Wow.
Anyway, all right. So this whole thing about God creating us uniquely, to honor, to serve him, to do all the things that we do, to sing the way we sing, the variety that we have, using our digits to play instruments and everything else. And of course, did you try to touch all your digits with your
I
thumb?
saw that, and I didn't realize with the holding of the pen, so
Yeah.
I was reading that, and I'm like, oh, it is.
Yeah, there's
You
three
use the- yeah,
points of
the
contact there.
tripod.
Yes, to
Oh, I
teach
never
kids how to do
thought
that.
about it.
But see, all of our digits, we can touch any two of these.
Yeah,
You can touch these two, those two, these two, that two. You can separate them like that.
oh,
What's that sign in Star Trek or whatever?
right, right,
Yeah, the Vulcan
the
sign.
Vulcan, right.
Oh, she's starting.
Pardon?
I was thinking of more.
No, that's the start.
Yeah. But to me, it's just amazing how God created us. All the variety, the abilities, everything else, and not two of us are the same. And 1 Corinthians chapter 12, a fascinating passage. 1 Corinthians chapter 12, a body is not just one member.
Right,
All the members work together. Where would the body be if everybody was an ear?
Right.
or 9. You know, God put all of them in there, and those parts of our body that are least respected are very valuable.
Yeah.
And the illustration being of the body of Christ.
Yeah.
You know, God needs a liver. Somebody's got to be a liver. Somebody's got to fulfill this position. You know, we're all valuable in every single way. Okay, any comment on your quiz? All right, this was a lot funner chapter, easier and everything.
Yeah.
Yeah.
Yes.
Okay. Only 10 questions. So, Judy, what'd you get?
9.
9 out of 10. Okay, and Sandra
And
and DL.
10.
Okay. And Edrika will give you a pass here. Okay. All right. I want to look at the video. The video is entitled Fearfully and Wonderfully Made. And this just, once again, will just absolutely amaze us at how God made everything in that sense of being able to reproduce, the development of baby and all of that. It's just beyond. I mean, the more you know, the more you just stand in awe. And so I want to show that video now. Now, do we need to do anything, Judy, to this? Just
The
push play?
display is already shared.
Okay, ready to go. Glasses fogged up with these masks.
What did you say yes on that?
yeah, I think we always say yes,
Where's yes?
right in
In the box.
in the box. In that-
Right here?
Yeah.
Yes. And then push play again.
Mhm.
Play again.
Yeah.
Should I make sure that.
Do what?
What happened to the Zoom window?
Oh,
Can we stop it?
I don't know what happened to the Zoom window.
Oh, there it is. It's still there. Sorry.
Still there?
Yeah, because it's still
Okay.
sharing. Okay, sorry.
right, you turn it up. Mine.
What is the question we're really asking?
Thank you.
Not when does life begin, but
You go a little bit
I see
louder.
that we should ask, when does a person begin?
Okay.
And this little fetus is in its 7th week of development. Technically, some would call
Thank
it
you.
an embryo. At this stage, the embryo magically becomes known as a fetus at about 8 weeks, maybe a week after the picture. And that change from embryo to fetus really is a change that says the basic work has been done. So 7, 8 weeks into pregnancy is pretty well, as far as making the fundamental organs of the body, the basic architectural work is completed. Not really completed, but the parts of it. When we leave that embryo stage, we go to the stage we call the fetus. We're really talking about maturation, maturity of the parts. Well, the story begins very early, when we address the question of when does a person begin? And I think the only way we can really address this question is to look at the Word of God itself. In Psalm 139, verse 13 and 14, we see where I found the title for this lecture. For you created my inmost being. You knit me together in my mother's womb. I love that knitting. That word knitting and weaving appears quite often.
Question one.
In fact, my field of expertise, the section that I did for the Bible dictionary,
Get it together.
and the area
Okay.
Yeah, the first one is to be knit together or woven. Did you hear him say that? In Psalm 139. Now, his translation, let's see, what does the King James say? All right, Psalm 139, verses 13 and 14. For thou hast possessed my reins, thou hast covered me in my mother's womb. I will praise thee, for I am fearfully and wonderfully made, marvelous are thy works, and that my soul knoweth right well. And I think the word thou hast covered me in my mother's womb. He's translating that. Probably some other translation would translate that knit, like a knitting things together, weaving, woven, knit together. So he's talking about our skin being knit together. Okay.
which I would be somewhat expert, is a term called histology. And histos is a Greek word which basically means fabric or tissue or knitting. So you might say I was an expert on knitting. When the early microscopists began to look at the body, magnify things, they thought, my goodness, it's woven. Everybody we look, we see weaving. Our skin is made of collagen fibers, which are very, very tough. They're so strong, they're stronger than steel for the same cross-sectional diameter. They're less elastic than steel. And yet, look at this, it's stretchy. How is that possible? It's possible because of the knitting, because of the weaving. It's the way they're woven together. You weave one way and it's not stretchy. That's the kind of architecture we have in the eyeball, so that it doesn't change shape. You weave another way, it's more like a double knit suit. It can be stretchy. So indeed, we are knit. We are woven, and the Lord knows that. He says that we're knit together in our mother's womb. And the psalmist says, I praise you because I am fearfully and wonderfully made. Your works are wonderful. I know that full well. Why, if I were to ever do a modern translation of the Bible, I won't, so don't worry about it. But if I were to do a really modern translation of this verse, here's the way it would read, and folks would know exactly what it says then. I praise you because I'm fearfully and wonderfully made. Your works are wonderful, and that's like a no-brainer. Isn't that what the Bible's telling us? We know it full well. It is so obvious that when we go before the judgment throne of God, there won't be an excuse from anybody. You had all the evidence you need. That's why I don't even attempt to prove or argue that there's design and elements on. Of course it's there. Let's just revel and enjoy some of the things that God has brought to you. Well, when do we become a person? First of all, the Lord recognizes his person, and I would define a person in terms of as a person who is known God. Someone with a soul. Would that be a good definition, at least for a Christian? Known to God, can you imagine a person?
Okay, number two.
No,
Yeah, who is known to God. That's Psalm 139, verses 15 and 16. My substance was not hid from thee when I was made in secret, curiously wrought in the lowest parts of the earth. You'll probably amplify this. He's using the NIV, if you notice. And yeah.
But it's not known by God. It's not known by God. There we get into things that are sort of out of our realm. In Psalm 139, it says, "My frame was not hidden from you when I was made in the secret place." It's kind of a name for the womb. Can't really quite get at it. Something's going on there. When I was woven, oh, we're back to weaving again. When I was woven together in the depths of the earth, kind of another euphemism for the womb. Your eyes, that is God's eyes, saw my unformed body. Not a lie, that settles it right there. That settles the abortion issue. God is looking on. As the baby is developing in the womb, God is checking. Your eyes saw. That means we are born of a developing the womb. We are born right before the eyes of God. That's not something that I do. Oh, and then we get into something I don't even want to think about. All the days ordained for me were written in your book before one of them came to be. What that suggests to me is that our personhood of God was no one even before the world was born. And that's not something we can act on. That's a matter that God can deal with. He just told us that he knows us that well. But that's not something we can act on. We try to figure out what a person is. We're going to have to go by something that we can see and understand. And so we're going to look into the womb and see what goes on, starting from as early as we can start in the fertilization process. And before we do that, we need to read Ecclesiastes. You know, when I was a professor at the university, it's often easy to get the big job. I think every professor who's a Christian, at least, I would urge the others to do it too. I want to read the book of Ecclesiastes at least once a year. It just kind of lets the air out. And before I would give a lecture on embryology or how the bones develop, I always like to think of this verse. As you do not know the path of the wind or how the body is formed in the mother's womb, so you cannot understand the works of God, the maker of all things. What a way to start out. We're basically told, you can take a look, but you're still not going to understand. We'll understand something. We'll learn something maybe we didn't know before, but we're not going to hit the bottom on this one. You'll see that as we go along. So with that kick off, let's just look at that secret place. This is the womb. It sets low in the pelvis, down between the hips down there. As you can see in this picture, it's got like some little water wings that go out each side. And they kind of hold it in place so it doesn't drop too far forward or back. And from the uterus, there's a couple of arms called the oviducts. You can see them out there labeled oviducts, which is just fancy for egg tube. And these oviducts are kind of like this. I think of the atmosphere, and the earth comes back, you know, the uterus is the body, the arms go up, and the hands are the ends of the oviduct, and there's fingers on the hands, and there's fingers on the end of these oviducts, or finger-like processes. Where do the eggs come from? Well, the eggs come from an organ called the ovary, which basically means an organ that produces eggs. So you see it's all pretty simple, actually, through the names. And the eggs are going to leave the ovary and enter the oviduct. And that already, as far as I'm concerned, we have a miracle on our hands. Every 28 days, normally, an egg will be released from the ovary. The egg will be released first from one ovary, then the next month, the other ovary, and it takes turns, left, right, the curves, the big curves. Now, if you remove one of the ovaries, it becomes damaged so that it can't no longer produce the ova. The other ovary has the considerable good sense to just go right ahead and produce an ovary. Compensatory response. So anyway, the eggs are produced, and when they're produced, they're ejected out of the ovary when they reach just the right level. And when they're ejected out of the ovary, the trick is you need to catch it. And the oviduct, with its little fingers on the end, come right down on top of that ovary and kind of feel around and see where the egg is coming out. and then it parks there, and it catches the egg. Sort of like if the catcher would walk out to the pitcher's mound, take his glove, put it over the pitcher's fist and say, all right, pitcher, I think I can get this one. Because you see, you better get it. If you miss and the egg doesn't go in the oviduct, it's out in the peritoneum. It's a space around all of our organs. It can implant there and start to develop. And that will become fatal to both mother and child. All other next pregnancy. So it's very important that the oviduct catch the egg. Let's look at this in a little more detail. We'll look at one of the ovaries as a drawing. These are wonderful drawings from Frank Metter, without whom I don't think anybody would get through medical school. If you look at these drawings and study them. Inside this ovary, we find the eggs, and they start out as developing follicles. You can see them up here. And when a baby girl is born, as soon as she comes out of the womb, she has approximately 400,000 eggs ready to go. And no more are made. The newborn baby girl has all the eggs she's ever going to have. 400,000, many of which will not form children. Isn't that just as well? 400,000. Even the Lord, who's told us to be fruitful and multiply, knows that that's way too many arrows in our quiver. So about every month, every 28 days, about 30 or 40 of these little oocytes, we call them, will start to develop. A little cohort, if you will. Start to become larger, and they will build up cells around the outside periphery of the egg, and it'll produce a kind of a cyst. It's a hollow ball with fluid inside. You can see them up there, here and here. It gets bigger and bigger and bigger. The egg is this part right here, this little round thing, and that egg will eventually be released through a little opening in the surface of the oviduct. If the egg entering the oviduct is not fertilized, then a big change occurs. Because you see, after the egg is released, what's left of the follicle forms an embryo organ called the corpus luteum, which means yellow body. If we just called it yellow body, we would think it's all that complicated. So we'll give it the name. And this yellow body, this corpus luteum, is an important endocrine system that will be necessary for the support and development of the baby should fertilization occur. But if fertilization doesn't occur, this endocrine thing that's left over from the follicle after the egg is released, it just starts breaking down. It gets a signal saying, you know, this egg never did get fertilized. I think you just ought to shut the whole plant down. And so what happens, it breaks down and forms a scar. Now here, you are going to see the hand of God pretty often. The scar left behind from this corpus luteum, this endocrine tissue, is so large that you can take a microscope slide, hold it out at arm's length and see the scar, never mind the microscope. And by the way, the whole ovary is about the size of an almond. Not the whole shell, it's just, you know. So one whole ovary will fit on the tip of the microscope slide, and at arm's length you can see the scar. It's a big part of the ovary. And next month you're going to get another one of the scars. And next month you're going to get another scar, assuming fertilization is not good. And next month you have another. You see a problem? Any of you have scars? How long have we had them? I have a scar here I've had for 40 years. I'm sure I'll die with that scar. See, scar tissue just doesn't break down. Oh, we'd love to figure out a way. Plastic surgeon, they just make scars dissolve and go away with it. It'd be wonderful. You can't do that. It's like a solid, massive connective tissue. It's pretty much with you for life. And every time you ovulate, you get another scar. I would say 4 or 5 months. The ovary is nothing but scar tissue, and that means there can be no more life. Mammals do not exist. There are no people. It's pretty well over. I'll just open the questioning right now. We need a miracle right now. We need to have one scar in our body that gets totally dissolved. And that's exactly what happens. This the scar, which is called the white body, the corpus albicans, gets dissolved. Oh, well, surgeons often know how to do that. Dissolve scars. Product of care of God. Things we never even thought about that are going on. And I guess we just take for granted, don't we? Here's your basic game plan.
I'm gonna back it up just a little bit here. And
He's already given number 3, I believe. Yeah.
Yeah.
well, now, that doesn't back up
How to back
Take
up.
that line, take the,
right here.
yes, move that back.
Did get on 4,
I didn't get 4.
Yeah, we haven't gotten there yet. I'm just there.
And he's released.
You know, what he's talking about there.
Breaking down. Couple right there, isn't it? Except in the mother, there.
Well, lost the picture that quick.
You have to click on it when you get to it. I wasn't getting to it, right there. So click on it.
And so what happens, it breaks down and forms a scar. Now here, you are going to see.
Well, I can't stop it that quick.
The scar left behind from this corpus luteum, this endocrine tissue. And the oviduct with its little fingers on
All right, that's not where I want to stop it anyway.
come right down.
Anyways, talk about how the egg, once it passes from the ovary into the oviduct, it has to be caught
Mhm.
and then you talk about the scar tissue and stuff that's left behind.
Catches the egg. So like if the catcher will walk out to the pitcher's mound, take his glove, put it over the pitcher's fist and say, all right, pitcher, I think I can get this one. Now here, you are going to see
Go back a little further. Wait, then wait.
it'll produce a kind of a cyst, 400,000. Even the Lord has told us to be fruitful and multiply, knows that that's way too many arrows in our quiver.
400,000 little eggs inside of a baby girl when she's born.
So about every month for 28 days, about 30 or 40 of these little oocytes, we call them, will start to develop. A little cohort, if you will, start to become larger and build up cells around the outside periphery of the egg.
And you have to move the dot.
And
No, once you.
And in the case of evolution, if you can't get the egg down the oviduct, you aren't ever going to get a second chance to get it down the oviduct because it's the end of that part of the story. Well, I talk about irreducible complexity. You know, I don't think bacteria necessarily need a flagellar motor because not all bacteria have a flagella. These are all stars. Product of care of God. Things we never even thought about that are going on. And I guess we just take for granted, don't we?
Okay, let me just kind of catch you up there a little bit there. On question number 3, or statement here, the oviduct releases an egg which must be caught by the fingers of the oviduct and then transported towards the uterus. Now he's going to talk about the transport. I think I got it at the right place.
Here's your basic game plan. The egg is going to have to go from here into the oviduct, which is not away like it is there, but right down on the surface. Fertilization is going to occur right about in here. And then if the egg is fertilized, the egg needs to move down the oviduct to the uterus where it can plant and develop. Sperm cells, on the other hand, need to go the opposite direction. They need to go up the uterus and out into the oviduct. Things need to go 2 different directions at the same time. Egg needs to go down, the sperm needs to go out. You can say, well, I think I know how the sperm gets there. It's got a little tail, it wriggles the tail with the gelatin. That's not how it gets there. Sperm will get there even if the tails aren't active and moving. The musculature of the mother's uterus and oviduct actually moves the sperm out to the right. And along the way, the sperm, by the way, is completely incapable of fertilizing that egg. That seems to be a problem right there, doesn't it? Except in the mother, there are chemicals that we we say capacitate, make the sperm able to fertilize. So without capacitation, pretty much the end of life. The sperm arrives, the oviduct is coming down. How do we get the egg to go the opposite direction? If the muscles are bringing the sperm up, how does the egg go? Because let's face it, if the egg just stayed in the oviduct, you see a problem there, fertilization can occur. The egg wouldn't go any further, it would implant in the oviduct. And sadly, that happens from time to time. It's called a tubal pregnancy. It's a medical emergency and will kill both mother and child unless something is done. That'd be the end of life right there. If you don't move the fertilized egg down the oviduct into the uterus, you don't have to even worry about what comes next in development because it isn't going to happen anyway. And in the case of evolution, if you can't get the egg down the oviduct, you aren't ever going to get a second chance to get it down the oviduct because it's the end of that part of the system. So I talk about irreducible complexity. You know, I don't think bacteria necessarily need a flagellar motor because not all bacteria have a flagella. But if you can't produce offspring, that's irreducible. Let's see how that works. That little box, we're going to look at that part of the wall of the oviduct. There it is in the microscope. These are tall columnar cells. And up at the top, you see what look like little hairs. Okay? Those are called cilia. Each of those cells have thousands and thousands and thousands of little cilia. They're so tiny you can't even see one in a light microscope. You say, what do you mean? I'm seeing them up here. You're seeing them collectively. The way you can see hair, you can see that there's some hair, but you can't see one hair. And so these cilia are so small, even under the microscope, you can only see them collectively. Can't quite resolve one all by itself very easily. And these cilia beat. And going down the oviduct, they're just trillions of these cilia. So how do they beat to move the egg? Well, we could say you just sort of fire the pistol and they all start beating. Well, imagine if all those trillions of cilia just started growing this. Would that move the egg down the oviduct? Maybe work up a little foam in the egg. I think I'm on to it. It's like window wipers on a car. They go like this, right? All of them together. Would that move the egg? No, the egg would sort of go forward, backward, forward, backward. Oh my, you know what the movement is? It's a metachronal rhythm. Isn't that incredible? You say, what's a metachronal rhythm? Have you been to a ball game where they do the wave? That wave they get going in the stadium, that's a metachronal rhythm. Ever see wind blow across the wheat field, those waves that go through the wheat? That's a metachronal rhythm, and only that can move the egg in a coordinated way. Let me give you a little example of how the cilia beat. That is a metachronal rhythm. Can you think about this? Can your mind bend that far? Trillions of these, thousands per cell, all interacting collectively down the oviduct in concert, setting up an integrated metachronal rhythm without which the egg wouldn't go down the oviduct, without which there would be no people, no mammals. It'd be over. And don't say, hey, look, if you're evolution, we'll get it right next time. We're going to work on this. We'll come back. It's over. This is irreducible. This truly is irreducible.
Okay, that's question number what? 4? Okay. The trillion of cilia, the little bitty fine hairs in the oviduct move with a synchronized metachronal rhythm. There it's spelled out for you, which moves the egg down the oviduct. Now, you all know what that rhythm is? Does that make sense to you?
Cool, James. No.
The what?
Nothing obvious.
I mean, it makes sense.
It's been silly.
Okay, it's like the wave in the baseball stadium. Okay, we get started, the next person picks it up, the next person picks it up,
Right.
keeps going so that the wave travels. Then they drop their arms. And so that's these cilia, trillions of them. They get started, but they're not all moving at the same time. They go in a wave that carries it forward. And basically his point is, if they didn't do that, the egg would never get there. That's the end of life. Evolution's dead in its tracks before it ever gets started. Yeah.
Well, let's look at the whole pattern of reproduction. The egg is released, and when it's first released, you have about a 12 to 24-hour period of time during which fertilization can occur. If it doesn't occur in that window, it's not going to occur. So sperm will be up in this region at the beginning of the oviduct. If they're in this region at the time the egg is here, there is a good possibility that one of the sperm at least will manage to penetrate through and fertilize the egg. And if it does, the fertilized egg will move down the tube. It will go through its first cell division after being fertilized. And here at 30 hours, we would have the first 2 cells. So what was 1 cell becomes 2. Let's look at this fertilization event a little closer. This is a cross section of the oviduct, cut right across it. And inside, would you believe it? When I cut this section, I happen to hit the egg. You get the picture, you have to think of a basketball sort of floating in space someplace in a very long hallway. You make a random cut across the hallway and you hit the basketball. And so that's what we managed to do. There it is, right there. There it is. Incredible stroke of luck, some might say. And around that ball, see the ball right in the middle, that's the egg, unfertilized. Around that ball is a bunch of messy looking cells. No little blue dots there, they're just cells that accumulate around the egg. There's a very interesting scientific name, these cells. They're called the cells that accumulate around the egg. I'm not going too fast. What we call it is the cumulus oophorus, which is the cells that accumulate around the egg. You think, do we need these things? Without these cells, we wouldn't be. These cells, the cumulus, secrete a sticky stuff. And it's this sticky stuff that the cilia get a hold of to move the egg. They've done experiments where they've stripped these cells off and put an egg into the oviduct, studying rabbits. And the cilia just make the egg go round and round, sort of like a ball with the nose of a seal, and it's spinning. It doesn't go down the oviduct. Without the sticky goop made by the cumulus cells, it's pretty well over. You won't get a second chance to get it right. You need to get it right first time. Now let's just magnify that egg cell with its investing cumulus cells. Here it is at higher power when we do this. Inside of this big cell called the egg, you'll see there's a little blue dot here. And that little blue dot are the chromosomes, it represents the chromosomes of this egg cell. You can see how much cytoplasm there is compared to the size of all of the chromosomes. And would you believe it? It's like making a section through a long hallway in which a basketball is in three-dimensional space. You not only hit the basketball, but inside the basketball is a little BB, and you hit the BB dead center. Would you mind if I just sort of stood here and gloated over this picture for a while? And those are the chromosomes, because when that egg is ovulated, it goes to form the first, what we call meiotic division. And it waits there, but the chromosome's not pulled apart, but the spindle ready to pull them apart, and it won't go any further unless fertilization occurs. Then it will go on. At 12 to 24 hours, we have fertilization. The fertilization process in itself is just incredible. There could be 100 or more sperm in the vicinity of the egg, and it's essential that only one sperm fertilize the egg. If you get 2 sperm in there, we call that polyspermy, and there's no possibility of getting a viable offspring here. It will spontaneously break down. The sperm cell has 3 barriers it has to get through to fertilize. First, it has to get through the cumulus. No way to get through the cumulus. You just can't get through. So that's pretty much the end of life right there. Except the sperm makes a highly specific enzyme that digests its way through the sticky stuff of the cumulus. Had a stroke a lot, like the evolutionists, without this, it would have been over. You have to have a specific enzyme to get through the cumulus. You're through the cumulus and you're down to the red layer. You see the red layer? That's a shell. You didn't know our human eggs had a shell, did you? Hey, it's not a hard shell like on a chicken. It's a kind of like a skim of jello, you know, a gelatinous, tough jelly-like shell. It's called the zona pellucida, which is fancy name for clear zone. The sperm needs to get through that, except no way the sperm going to go through that. Is it going to go through that clear zone? It's a barrier. But there's a second enzyme that specifically digests its way through the zona, without which there'd be no fertilization to the end of life. Now you're down to the membrane. And remember, we have two cells of completely different sources, one from father, one from mother. They should have nothing to do with one another. In fact, they should build sort of resistant responses, but they don't. As soon as the first sperm cell, it might be just ever so slightly ahead of the next one, like a horse race, as soon as it touches the membrane of the egg, there's a quick little system that makes sure that it's the same species and all that sort of thing. And if everything is right, the membrane of the sperm and the membrane of the egg open up so that the contents of the sperm goes inside of the egg. And that's the first step in fertilization. Remember, you have to keep the second one out. How do you do that? Oh, this is so wonderful that I'm not sure you're going to be able to contain this stuff in the tiny eggs. Just under the surface of the egg cell membrane are a whole bunch of little granules called cortical granules that are right near the membrane. And they're full of an enzyme called ovoperoxidase. And as soon as that sperm touches the egg cell membrane, in just a fraction of a second, the granules explode, send their contents out into the space where the red shell is, and harden the shell. Any sperm not right out the membrane get locked right where they're at. What sort of a creator do we have? What are his limits?
Okay, did you follow all of that?
It sounded like it was.
Yeah.
No, it was sparkling. But it
What are enzymes?
still like.
You know what an enzyme is? When the sperm gets to the outside of that egg and it's got all this sticky stuff, it secretes a certain enzyme that dissolves the sticky stuff. Now, enzymes are simply proteins that have a special job. Proteins are a molecule. That's how small this is. Remember, atoms make up molecules. It's just a molecule of atoms, but it's a very specialized one. And the job of enzymes is to cut through, to break up whatever it is, to dissolve what keeps them held together. And so it secretes a very specific enzyme, lets it go through. When it gets to that next barrier, it's got a different enzyme, and it secretes it. It gets to the third barrier, it's got another enzyme. I mean, how does this one little, basically it's a single cell as far as the sperm is concerned. The egg is a single cell. That single cell has different enzymes that it squirts out immediately at different times when it gets certain resistance to let it pass through. And then once it gets through, then these little granules inside there, right next to that inner wall, the moment that that sperm passes in there, they explode and harden it so nothing else can get in. Irreducible complexity all along the way. I mean, it's just amazing how it's designed. And so question number 5, as soon as the first sperm touches the membrane of the egg, an enzyme is released, which hardens the shell so that no other sperm may enter. Hey, everybody get that? All right. But it's just, I mean, this is just a fraction of how complex we are. Fearfully and wonderfully made. And this is, we haven't even, I mean, this is before fertilization. Very, very complicated. Everything has to work in order.
Once that happens, once fertilization happens, once the genetic material of the egg and sperm are together, from that moment on, if you do not interfere, if you let it be, if you let God look on and watch and monitor the process in the womb, if He so wishes to bless you, a baby will be born. And I believe it's from this moment on we ought not to interfere. It's the first chance that we, with our limited human minds, can perceive that there's something here that is forming a person known to God, because God said He knew him even before the fertilization occurred. He certainly knows him now, or her, and watches on. Psalm 51 is sobering, because not only does a person begin then, but like all persons on this earth, the person's the center. A fertilized egg is a center. Well, how about that for a definition of the person? Look at Psalm 51, verse 5 and 6. Behold, in other words, the psalmist wants to get your attention. This is important. Behold, I was brought forth in iniquity. That means coming out of the womb. I was a sinner. As the baby emerges, he's a sinner. But he goes further than that. And in sin, my mother conceived me. That's the fertilization event. That's from the very beginning when life of the individual began and the person began. So we are sinful from the beginning. Behold, you desire truth in the inward parts, that is in the heart. And in the hidden part, you will make me know wisdom. Since we are a sinner, and we're just a sinner from the beginning, we pray to God as the psalmist did in Psalm 51. To me, verse 10 and 11 here are simply one of the most important verses of the Bible. We spend a lot of time talking about creation. But the creation of heaven and earth is not the really big creation. The creation of heaven and earth, even when God says, oh, and He made the stars also, as though there's something else. Oh, yes, all the stars. By the word, by speaking the word, there is a more phenomenal creation. There is a greater creation than that. And here it is. Create in me a clean heart, O God, and renew a steadfast spirit within me. Do not cast me away from your presence. Do not take the Holy Spirit from me. See, when God created the stars, He didn't have to argue with them. They didn't put up a fuss. They didn't say, we'll get together next week, we'll discuss this again. Adam and Eve didn't put up a fuss. He spoke, and it was. But when man fell into sin, he's got this stony heart. The Bible says he's at enmity. He's at warfare with God. And God needs to come in and create a new heart. I call that the second creation. And the third creation is gone here, a place for us. Now back to our oviduct. We get out here to 30 hours after ovulation. We now have 2 cells. It's divided. We're on our way. Remember, every time you divide 2, 4, 8, wow, you pick up cells in a big hurry, don't you, doing that exponential growth. This is what the 2 cells look like. In a human, the egg is just divided, fertilized egg, and it's the first 2 cells in it. And if you look, you can see the shell, the zona pellucida going around it. Now, when you get into the adult or later development, the cells are all held together by little buttons called desmosomes, kind of keep them from falling off and getting lost. There are little glues and buttons that hold them all together. But at this stage of development, there's really nothing holding the cells together except the shell. If the shell is defective and breaks down, those 2 cells can separate. Now, this is so heavy duty. You may want to plug your ears and not hear this because you're probably going to worry about it. But I've learned to just get blown over by God and just say, Lord, you know, I don't have to. If they separate, you get 2 people. And if they stay together, you get 1 person. Each of you in this room could have been 2 people. Maybe some of you are. Are they identical twins here? Because an identical twin is a virtual clone. I have people say, oh, if they make a clone, would it be a monster? Would it have a soul? I say, you probably had a clone in your life once or twice. Really? Yeah, an identical twin, it's a clone. But when God makes a clone, it works. You see, because these aren't germ cells anymore. This is not an egg anymore. This is not a sperm. These are body cells, you might say at this point, albeit embryonic ones. And if they split two, if they stay together one, how do we explain that? We don't. We leave it up to God. He knew them from eternity anyway, so. No, most twins are not this way. Most twins are where instead of one egg ovulating, two or more ovulated, and then they got fertilized. Now there you can have a male and a female, right? But here they're going to be the same sex. In fact, they'll have exactly the same genes. You think, man alive, they must move at the same time. No, they each have their own personalities. One can safely be saved and one not. In fact, if you want to really think about what little we know about genetics, identical twins have exactly the same DNA as far as we know, but they have different fingerprints. Where are they coming from? I'm mainly here to get your questions, not answers. Well, we move on about 3 days. You got a ball of cells, which is given the scientific name of ball of cells, which of course we call memorial. And then by about 4 to 4.5 days, the ball was in the uterus. And at about 5 days, that little ball is going to implant. And we'll talk about that. So we start out 2 cells, 4 cells, and then a ball of cells. You just keep getting, actually it doesn't get bigger. It's like cutting up a pie. The pieces don't make the pie bigger, they just subdivide the pie. So at first the cells really don't get bigger. But at 4.5 days, this cell, this ball of cells becomes hollow, and we call that hollow ball a blastocyst. And that's not to be mean as being less than human, which just has the scientific blastocyst. And it is like a cyst. And it's this blastocyst that's going to penetrate into the wall of the uterus that you see in red up there. It's like planting a seed in the field. At about 5.5 to 6 days of the implantation. This is after ovulation. That implantation occurs. This is a miracle you're looking at right here. There's no way on earth that blastocyst should implant in the uterus. First of all, it's a different person. It's a different tissue. It doesn't have the same antigens as the mother, no more than your son or daughter. It has exactly the same genes as you do and the same antigens. If you take tissue from your son or daughter and inject it into the body, you will build an immune response against your own children, against their tissue.
Okay, now, that happens to be number what? Number 6? Okay, a totally different person. Now, what's the significance of that? You know what he's saying?
No 2 people are alike.
Well, more than that, your body is prepared to reject any foreign influence. You talk about if your son or daughter, if some of their material gets ingested, or not ingested, but invested in that person, then your body is going to have a response to reject that. And that's the immune system. The immune system rejects all kinds of foreign objects. So if you get a disease, it's going to build up an immunity against it. If even your own daughter or son or somebody else was to get some of their tissue in there, it's going to build up a resistance. It's going to have an immune response to get rid of it.
I know this is a little off subject, but that's from what I've studied a little bit, that's kind of where HIV/AIDS came from, the rejection of the blood sperm going somewhere it wasn't supposed to go, meeting with other blood and chemically being rejected and causing that sickness, helping cause that sickness.
Yeah, and I don't know. I mean, I'll just accept what you're saying because I've never read about HIV, but
I can't really regurgitate it the academic way, but that's basically how it happened. Because blood, the sperm is blood.
well, no, it's not really not blood.
Well,
It's a single cell.
yeah, but isn't there blood in it, or it come from blood, or it's blood?
Pardon? There's no blood. There's no blood there yet.
Blood is sperm. Okay, but whatever that sperm is wasn't supposed to go where it went. And
But see, the
that's
miracle
not where God designed it.
is that it's welcomed.
But the body rejects.
No, I mean, the womb is accepting it.
No, the womb, I'm talking about homosexual activity.
Oh, I'm sorry. Yeah.
That's what I'm talking about.
But even in the womb, it's still a different person. It
Right.
should be rejected,
But it doesn't.
but it's not.
It's supposed to go in a womb.
Yeah. But everything else in your body should reject
Something
that.
different.
But this particular egg now, a different person from the mom, and yet it's accepted by the mom into the lining. See, it's not rejected as a foreign object.
Right.
Yeah.
Hmm.
And he said, we don't have to understand why. That's just the way God made it.
Right, right.
Yeah, okay.
Come on in.
Come on in.
And it comes in and it's not rejected. It should be, but it's not. And if it were, maybe the end of life, we never get another chance at that. That's irreducible complexity. This group of cells right here, that's the baby. They want that's a baby. What are these other cells that form a ring out here? How are they interested? And the ones that form the ring are called the cytotrophoblasts. I won't even bother you with this name except that it really gets interesting. The cytotropoblast cells fuse together. So you got two cells, they fuse together, you get one cell with two nuclei. And another one fuse, you get one cell with three nuclei. Right? We call this a syncytium, so the name changes eventually to syncytial trophoblast. And it is these syncytial trophoblast cells that are implanting at about 6 days after ovulation that secrete the chemical called HCG, human chorionic protein. That's the chemical we use for determining whether someone's pregnant or not. The little tests are looking for this HCG. So the earliest stage you can tell if somebody's pregnant would be about 6 days, right when the implantations occur. And these syncytial trophoblasts are the only cells that have the ability to penetrate and go into the uterus. Without these cells, we have. These are the cells that can penetrate through the uterine wall. In fact, these are the cells that are going to make the placenta. Now, remember what these are? Syncytial trophoblast fused cells. The whole placenta, the whole surface of the placenta is one cell. About half the size of the basketball court. Biggest cell in the body. But it's really only about this big around. It's folded and folded and folded and folded so that it gets all that surface into a little area. And it's all one cell and it's seamless and it separates mother's bride from baby's bride. But we're getting into the story. Let's look at, there's the syncytium penetrating through the uterine wall as the little fingers going through. Here it's
Okay, so you got that the placenta is one continuous cell, the largest cell in the human body. And the interesting thing we're going to find out here is that the baby makes its own placenta. The mother does not. Yeah. Okay, ready to go on?
Mhm.
All right.
penetrated a little further, the blue and yellow up there, that's the baby part. Basically, the baby is told, would you mind waiting a little while? You see, because it isn't going to do any good to work on you at this time. We need to create a plug-in. It's like having a nice TV booth. You can't plug it in. And by the way, you plug a TV in, is it simple? Is it just 3 holes in the wall? Is that all it is? You take and plug into any 3 holes and the TV runs? No, there's a power plant hooked on the other end of that plug. And the power plant is more complicated than the TV set. And that's the way the placenta is. It's one of the most incredible organs in the body. There's nothing else quite like it. I call it a super organ. When I taught my medical students, they all knew I was talking about the placenta. That's a super organ. And you need to make this whole organ, or you can forget about the developing baby. It's a TV with no plug-in. Now, birds and reptiles, they're like battery operated. They have an egg with yolk in it, and so they just use up the energy that's in the yolk, whereas we need to be plugged in. Now, the red you see down there, that's mother's blood vessel. There's a lot of blood vessels in the uterus, and they're going to be brought into close association with the green, which is the developing placenta, huge syncytial trophoblast. Now we're getting close. There's a mother's blood vessel there. And when that syncytial trophoblast hits those arteries, one of the most incredible things you can think about happens. The ends of the arteries of the mother's uterus get eroded, so that the arteries just end, like cutting off a hose. There's about 20 arteries big enough that you can see them, maybe half of them or the blood vessel or so. 20 truncated arteries. Wow, you better have a nice seal on this placenta of this blood, which comes through at the rate eventually of a half a quart a minute. It is going to lead to some pretty serious complications. But we need to get mother's blood up there to give the nutrients and oxygen to the baby when we finally get around to working on the baby. The syncytial trophoblast makes a lot of hollow cavities inside. You can see it in the green here. And the blood is going to eventually flow into those cavities. See the red blood flowing into the cavities in the green syncytial trophoblast. Finally, you're going to have little processes all around the baby. And the baby's going to make blood vessels of its own. And they're going to be on one side of that syncytial trophoblast, that seamless cell. And mother's blood's going to be on the other side. And they'll never mix because the barrier between them is seamless. Eventually, the placenta just becomes a flat disc, but early on here, for example, at 40 days of development, it goes all the way around. And if you'll notice, the placenta is almost like hair. You see where the surface area is so big, you have all these little processes, each one of which has blood vessel inside from the baby. And then the outside of all this hairy processes is bathed by mother's blood. So there's a tremendous surface area for interchange. If you magnify just one of those little hair-like processes that are on the center, under the scanning electron microscope, you can see that these little processes have even tinier processes coming off of them, further increasing the surface area. So where you see black in this picture, that would be all of mother's blood. The baby's blood vessels would be inside of those little finger-like processes, so the materials and nutrients have to go across to get to the baby. Let's cut a cross section. See the red line? We're going to cut in these little microscopic, tiny little processes and look at inside. If we look inside, there it is, the baby's blood vessels, but not the blood vessels of the baby's body so much as the blood vessels that are in the placenta. This is a little blood vessel. This is another one. This is another one. The red blood cells you see in here belong to the baby and were made by the baby. The red blood cells you see just out here are red blood cells of the mother, and between the two is this incredibly thin cell, which is that seamless syncytial trophoblast. The nuclei have the good discretion to get out of the way and move to the side and make very thin areas across which gas and nutrient exchange can occur. So everything going from mother's blood to baby's blood has to go across either passively or actively. For example, water can just go across passively, you don't need to pump it across. Sadly, alcohol will go across from mother's blood to baby's blood passively. So a mother who consumes alcohol will be giving the same dosage essentially to her baby, and the baby can be born with fetal alcohol syndrome. A mother who takes some of these recreational so-called drugs, sadly, many of these drugs go across the placental barrier passively. So you can have a baby born as a crack baby from crack cocaine. Oddly enough, most of the things that are really important to the baby have to be carried across with special molecules. For example, for the baby to make its own blood, it needs iron. The only way it can get iron is from the mother's blood. And the iron has to be transported across from the mother's side to the baby's side with special proteins, one of which is called transferrin, that can come over here, pick up the iron, carry it across, and release it on the baby's side. What a miracle we got here. Just give it a second.
Okay, now, of course, that's number 8. Iron carries iron.
They don't seem to transfer that passively though.
What's that?
They didn't seem to transfer passively.
No, they're active. They require a protein.
Mhm.
Remember from the previous video that we saw
Yeah.
about the molecular trucks and stuff? Well, this transferrin is one of those molecular trucks. And it's going to go across that line, that boundary. It's got the ability to go through it. It's going to pick up the iron and bring it back. Just a little truck. Transport. I mean, it's just, all this is so small. Inside every single cell are these little molecular machines and trucks and all kinds of things that all have a special job to do. And they're proteins. Remember how the proteins were all made and folded and everything so that each one has a different job? Well, this is one of it. It's just made specifically to go and get iron and bring it back. And it has special privilege to go through that membrane. Now, beyond that, I'm stumped. How does it do that? I don't know. But all that's just nothing but molecules, a protein molecule that's a little truck. Amazing, isn't it? Okay, ready to go on?
Yeah.
All right.
This is kind of what the placenta looks like in the hole. You can see a couple of the arteries that are truncated in there. And they're just blasting the blood out, like going up to some bushes, all those little Billy we were showing you sort of look like branches of a bush. The blood vessels inside, and the blood just gets sprayed over them, and it's sealed so it can't leak out of the sides. Placenta is then really part of the baby, not part of the mother. It's really not in the baby's body. It's attached by a fairly long hose. And you have to make sure you don't kink the hose. Ask any mother that's, she'll tell you when the baby is in the womb, they do loop over, loop to loops, and they do wing overs and all those things. They do all this. How do you know about kinking? Too. This is so gorgeous. There's a special jelly not found anywhere else in the body. Wharton's jelly. The blood vessels are in there, and when you bend it, it resists kinking the blood vessels. Evolution says, what an incredible stroke of luck.
Goofy stuff.
Now, the most amazing thing I'll tell you all that is that when the baby's born, this placenta comes out. First, the baby comes out, and then the placenta comes out as well, along with other membranes. And when that placenta unplugs, approximately 20 good-sized arteries, virtually truncated at their ends, are now open to the lumen of the uterus to spray blood at approximately a half quart per minute. You think this is that? You haven't heard the whole story. There is a mechanism in the placenta that suppresses blood clotting. Now, to get the picture, a hemophiliac, right, one that can't clot his blood, with 20 severed arteries, releasing blood at a little over a half a quart a minute. Anybody see a problem here? How on earth is anyone surviving this? People have said this is the biggest wound any human being gets and lives to tell a story. Biggest one. How bleeding to death is prevented is so amazing. When the blood vessel breaks apart, part goes with the placenta, part stays with the uterus. There's a little muscular sphincter, like a string on a purse, that, fortunately is on the side of the break towards the uterus, that squeezes suddenly and pinches off the blood, just sort of like a surgeon would use a hemostat to pinch the blood vessel. It all closes down so that in the normal delivery, you may use a small cup of blood or something like that. Is this not? It's absolutely incredible. Flat out miracle. Yet people look at it and say, I'm saying design, there's no design. What do you think? Give them a better example?
It's number
Give
9.
them a better example.
Blood.
If they say, I don't say design it, forget about it. We're not going to change that mind with scientific arguments. The only thing that can change that mind is the power of the Word of God in the Holy Spirit. That's the only thing to do. And bless you, it's not up to the test. It was nothing more than the Word that spoke the very universe into existence. Can that Word and the Holy Spirit change your hearts? Yeah, it can. You really can. Well, 4-week embryo, kind of interesting, there he is in there, in an embryo, got the little yolk sac. The yolk sac, by the way, doesn't really make yolk. Blood vessels are developed in there in the earliest stages of blood formation. Let's get it out of the way. Evolutionists get really excited about these 4-week embryos and say, look, it's got paddles, this is the fish stage. Oh, what gills? I had a teacher, my daughter had a teacher in public school that said the baby uses the gills to breathe under the amniotic fluid. Wow. You can see the heart creating there. The body's bent like a C because the nervous system grows faster than the rest of the body at first. And because it grows faster, it gets out ahead of the body. Notice the spinal cord has gone beyond the end of the body. That's because it's growing faster. If you look here, you see on the back, pointer, the spinal cord was growing so fast, it got way out here and the body has kept up. There's our so-called gill slits. I can tell you 2 things about the gill slits. They're absolutely true. You can bank on them. Number 1, they're not gills. Number 2, they're not slits. You get the idea? There are no gill slits. Now, what about that? Evolutionists look at it and say, there you go. There's your evidence for evolution. That's the tail stick. Well, as the baby grows, the body starts catching up, and what you see here protruding beyond the body ends up ending right about here, the smaller, just below the smaller of the back. That's where your spinal cord ends. And so then the body gets ahead of the spinal cord. It's not true. There's some little bones that develop down there at the end, and of course the spinal column has to end someplace, right? There's a linear structure. There's a head on one end, and wherever the other end ends, they're standing by. Will be an evolutionist pointing saying, see, okay. But how can you avoid having the other end? I tried this with the robots. 2 ends, I cut off one. Every time I cut off an end, I still have 2 ends. So Ernst Haeckel, back at the time of Darwin, talked about these gill slits being reminiscent of our evolutionary development. So the embryos in their development went through all the stages of their evolution, at least many of them. And he showed how similar the chicken and the dog and the pig and the human were. But it turns out that these drawings he made were completely falsified. There was a hoax. The man was a charlatan, essentially. It's not like that at all. And yet, years ago, Dr. Spock, remember him? You couldn't have a baby without reading Dr. Spock. It was considered a handbook for the babies, the manual. And Dr. Spock, in his book, Baby and Child Care, says each child as he develops is retracing the whole history of mankind, physically and spiritually, step by step. A baby starts off in the womb as a single tiny cell, just the way the first living thing appeared in the ocean. Weeks later, as he lies in the amniotic fluid of the womb, he has gills and fish. Notice he even says we're tracing spiritually our evolutionary history. Well, that's just simply isn't true. This has been known to be untrue for a long time. There's a paper that was in a journal some time ago.
Okay, that whole picture, number 10, it's a total fraud.
False/goofy stuff.
You said it's total fraud.
I said hoax too.
All right, hoax or fraud, either way.
Okay.
Yeah. Yeah, but I mean, you see, the pictures and stuff are basically designed to kind of give that impression. And I was taught that in school. And I don't know how recent he was talking about his daughter being in school, but I think they've kind of done away with that because it's so false. But trying hard to make it look like evolution.
And up at Haeckel's embryos are just simply a fraud. That if you look at the real, compare the real embryos, they're not similar at all between the different animals. I mean, they have general overall similarity, but the fundamental differences that he did not show. In fact, many evolutionists have said the same thing. This whole embryology, this recapitulation that our embryo develops, kind of reminisces on our evolutionary history, that is just simply not true. Paul Ehrlich, you probably heard of him, he says this interpretation of embryological sequences just won't stand close examination. Its shortcomings have been almost universally pointed out by modern authors, but the idea still has a prominent place in biological mythology. And where do you go for biological mythology today? I suggest any high school biology textbook or college, for example. Biology Principles and Explorations by Holt and Reinhardt, widely used textbook. There they are. The whole recapitulation myth, as we call it today, is a myth. Lined up in a row, showing how the embryos retrace their evolutionary history. On another book, this is McGraw-Hill's text, same thing. Evidence from embryos, see our evolutionary ancestry. It just goes on and on. What are those little folds anyway? Well, they have nothing to do with gills and respiration. Those folds we see in the neck go on in the embryo, develop into a number of different organs. And you see some of them illustrated here. The ear canal, some of the bones of the middle ear, the eustachian tubes, the thyroids, the parathyroids. There are a number of structures. Notice none of them have anything to do with respiration. They are completely separate structures. They are not gills. Go back to our little embryo. We need to just jump ahead now to the end of the story because embryology is so complicated. I couldn't talk about any specific cell, not the heart, not the liver, anything. So let's just jump ahead. There we are. The baby's in the womb, ready to come out. Oh, praise the Lord, he's got the head out, not the right. You see the umbilical cord there? No kinks. Oh, we've got a problem. I wish we would have thought about this. Have you heard about the fellow that built a boat in the basement of his house and then discovered he couldn't get it out of the door? Don't you just hate it when that happens? Look at the incredible sequence of miracles we've had to do to get to this point. And if I got sad news for you, no way are you getting the baby out of that womb because the opening isn't big enough. What's your problem with that? And I'm not just talking about dilation and soft tissue. You can't get it. Let's look at a lady's pelvis. It's very different than a male pelvis. Lady's pelvis is more open. Male pelvis is more like a funnel. And the head would be right down there in that opening you see at the center. You see the so-called tailbone in the background, the coccyx, which evolutionists say, hey, there you go, that's the tail. It has no function except the minus of our tail evolutionary ancestry. Nothing could be further from the truth, as I was shown. You see, the baby's head isn't going to fit through that bony circle. What are you planning on doing about that? Miracle. Just nothing of a miracle. There are three seams. Let me point them out to you up here. There's a seam right here. This is a good old sacroiliac and iliac bone. And there is a kind of a tight seam between these two bones here. There's another one just like it on this side. And finally, there's a seam at the front. So three seams that hold the three bones of the pelvis, this one, and this one, kind of together in a ring. And this seam has a little bit of give to it. That's why when you jump off a high building, keep just enough give there so you don't break the bones of the pelvis. Not nice. But for the baby's head to fit through, special enzymes, collagenase, must partially digest the ligaments that hold these bones together. And then it open up just a little bit. And now if you turn the baby's head just right, has to be turned like a key in a lock. It just fits. By the way, that little bone down there is the business bone of the body. See the tailbone evolution? I even heard an obstetrician say, well, that bone has no function other than the minus of their evolutionary ancestry. If you rank ordered how important bones were by how many muscles are attached from how many different directions, this would be the winner. How many of you following the tailbone? Boy, does that hurt or what? Three positions you can't stand to be in. Standing, sitting, and lying down. Those three you can't deal with. The reason is if you look down on that pelvis, all of these muscles that form the floor of the pelvic diaphragm come in from all directions and anchor to that one little bone that I prefer to call a coccyx, not the tailbone. It makes the whole floor down. Without this, wow, whoopie, all the materials in their body, we have an open pathway down. And the baby has to go through there and not only has to stretch out this orifice right here, but even when it stretches it maximally, the bony rim won't let the head through unless the ligaments loosen up and open up. My goodness, the birth of every baby is just quite simply
A miracle. That's number 11, allowing the baby to pass through. Okay, all right.
a miracle. And when the baby comes out, the problems are over. At first, its blood supply is all wrong. You see, the placenta has served as a kidney. A baby can be born without kidneys. A placenta is a lung. A baby can be born without lungs. The placenta is the intestinal tract. It doesn't need an intestinal tract until it's born. The placenta is the liver. The placenta is a large part of the endocrine system. The placenta does everything. It is super organ. And when the baby's born and is disconnected from the placenta, it better have all these organs ready to go for the first time. Or it'll die. And what do we do with the placenta when the baby's born? Into the OR tomb. We just throw it away. Would you at least give a prayer to God in thanks for that placenta? What an incredible, selfless organ. It does its job and it vanishes. It's so fragile that it breaks down. You can't even hardly take it in to show it to a medical student unless you run from the delivery room to the lecture room very quickly and say, well, quick. And when that baby was born, the blood vessels have been bypassing certain organs. Because you haven't needed the liver, the blood vessels have actually bypassed the liver. And because the lungs are developing, most of the blood supply bypasses the lungs. It takes a shortcut over to the aorta. But boy, when the baby's born, you better get the plumbing put back the way it's supposed to be. What happens is very sudden constriction of that blood vessel that was bypassing most of the blood away from the lungs. Now it closes down, and for the first time when the baby's born, all that blood from the right ventricle of the heart goes into the lungs. And down here in the liver, you were bypassing the liver, and the little bypass is closed down, and now for the first time you're taking blood from the intestinal tract and running it through the liver, because the placenta was doing all that before. And all this has to happen just as soon as the baby comes out. You don't have a whole lot of time to grow something new. Now, if the baby comes out a little early, 2 months premature, as my grandson did here, the lungs may not be fully developed. And the problem is that the lungs, if you think about a sandwich bag, a plastic sandwich bag with a little water in it, doesn't the side kind of cling? You ever take 2 plates of glass with a drop of water and put it together, you can't even pull them apart? That's because the surface tension forces are measured in tons per square inch. And the water inside of the lung, which is necessary, locks the lungs up just like 2 wet pieces of glass stuck together. You can't get any air in, you can't open it up. Because the baby at this stage hasn't gotten around to making a special surfactant that's a detergent that breaks down the surface tension forces that allows the lungs to open up here. And there are ways, thank the Lord, to deal with that. And we did with my grandson, but it was very troublesome. You know, he was 7 to 8 months here. That happens to be the age of John the Baptist. About 7 to 8 months when he first met Jesus. 7 to 8 months in the womb, not out of the womb. 7 to 8 months of development in the womb was the age of John the Baptist. In the womb of Elizabeth, and it says in Luke, for indeed, as soon as the voice of the greeting sounded in my ears, this is in the presence of Jesus, who was several months less developed. The babe leaped in my womb for joy. I have a question I want you to think about the rest of the day. What was the nature of the joy? Maybe the Bible is just speaking figurative way here. Mothers feel the baby quicken or move in the womb. No, God's word said, John the Baptist, the age of the baby you just saw, is still in the womb, leaped for joy in the presence of the Savior. Oh, there are things going on there that are way too complex for me. Now, we were born once, and it was an amazing process. But there's another birth process more amazing than what you've seen. And that's called being born a second time, being born again. And when Jesus told people that they must be born again, we get the comment of Nicodemus. How can a man be born when he's old? Can he enter a second time into his mother's womb and be born? No. That would be the easy way. Even I can sort of, in my wild imagination, imagine getting back in the womb again. But this born again is not going in the womb again. This is taking our condition of being dead in trespasses and sin and being turned around and sent off in a whole new direction, so contrary to the very nature of man. Greatest miracle of all. Right?
And you know, Jay,
Okay, number 12.
I think you said the heart and the lungs,
Yes. Yeah, the lungs and the liver is what he had.
lungs and the liver.
Yeah. And I don't know, DL, you slipped out just about that time. But what he's saying here,
After I got number 11.
what he's saying here is that inside the womb, the placenta does everything. So there's little blood vessels that bypass the liver. They don't need the liver because the placenta does that. Filters out all the impurities. It doesn't need the lungs because the mom is giving the oxygen and everything through the placenta. And so the moment the baby's born, all that shut off. And immediately then, those blood vessels that bypassed the lung, the liver, et cetera, they close down. And now all the blood is given to the lungs and given to the liver, et cetera, the other organs, so that everything works. Another miracle.
yeah,
Yeah, so,
And that's basically, I mean, this whole video is just miracle after miracle after
Yeah.
miracle after miracle after miracle. And if anything broke down in that process, there's no baby. And if evolution is still learning how to do this, it's all got to happen at the same time, or there's no baby. Just absolutely miraculous
it is,
how all of this happens.
it is.
And David, he says, when I was covered in my mother's womb, when I was knit together, he says, that my soul knoweth right well. It doesn't take a genius to realize we are a miracle.
Amen.
Not by chance,
No.
not just lucky, designed by God. Okay, any comments on that? Did you find that an interesting video?
It was, I learned a
I mean,
lot.
just so many things that we just never stop to think about. Mothers that have babies don't even know what's going on.
No, you're right.
Probably don't want to know.
That was
Probably couldn't
like,
understand that.
Yeah, and the fact that when that baby's born, then all the arteries that came from the mother, we say, what, 7 of them, 5 of them, something? How many of them?
20.
Was there 20 arteries
Yeah.
that all of a sudden are cut off?
Arteries.
And they've got a little sphincter muscle and just a little clamp that clamps down immediately. Otherwise she'd bleed to death. Yeah, all right. Very, very fascinating. Judy, would you like to close us in prayer, and then I'll give you your homework and everything else. You should go ahead and pray at this point.
Father God, we just thank you for just revealing to us again, Lord God, in a wonderful way, that we are fearfully and wonderfully made, Lord God, by you. I thank you for this class and the lessons that we're learning, Lord God. Help us to be able to just speak your truth, Lord God. As we talk to those that don't believe, Lord God, we just thank you for all that you do for us. Bless us as we travel home, Lord God. We just thank you for Dr. Anderson, Lord God, and him taking time pouring unto us the things that you've given to him, Lord God.
yes,
And we just pray that you would just bless Adrika in her absence, Lord God.
yes,
We thank you that, Lord, you will, and Lord God, she'll be here next week.
yes.
But Lord God, we just want to be careful in all things to give you the honor and the glory. We praise you in your son Jesus Christ's name. I pray, amen.
Amen. Okay, we're getting fairly close now. There's about, there's no class in 2 weeks. We've already been talking about that. Next week now, I want you to go over chapter, I'm going to skip a chapter, on purpose so that I can kind of coordinate with the other book here. And we'll get it a little later on, but I want you to jump over now. We had, what, 11 and 12.
Yeah,
So I want you to take chapter 14, Ancient Man, Genius or Primitive. And that'll be just a lot of fun too. That should be a good, easy chapter. And I'm just going to give you the one chapter,
okay.
okay? Chapter 14 is just 30 pages, even with some illustrations and stuff in it.
Okay.
And I need to remind you now that there's not that many weeks left. What about your extra reading?
Mm,
Got a book report coming.
mm. Yeah,
Have you started on it?
Okay.
I
I have a mind.
know you got it, but you gotta get going
Yeah,
here and write out your
right.
book report.
I'm not as far as I need to be, but I have started reading.
You're on the checklist, Doc. I got 7 classes, so
yeah.
I just started getting on 4 projects.
All right, well,
So you've been on that list.
yeah, so
To be done by-
just reminding you, this is only one chapter, so
Right.
probably be a good time to really get started on
Right.
your other reading,
You're right.
okay?
That's true.
Give it kind of a little break.
You're right.
All right?
I'll do
Okay.
that.
All right, well, you have a very good week and I'll see you then next week and we'll
Okay, you too.
see Enrique in person next week.
She's planning on being here next week. I think she was supposed to be in the next 2 weeks. But, you won't have classes.
Yeah, we won't have class that 1 week because of special meetings at church and you're all invited. We'd love to have you.
I'm gonna take the break.
I'll probably be doing a project,
Oh, uh-oh.
but that's for the invite.
Okay, so we gotta stop this. Gotta stop it. Screen share has stopped. Okay. Okay, what's that say? Are you sure you want to stop the recording? Yes, yes.